The debate surrounding NASA's handling of the high-rise images of the interstellar object known as 3I/Atlas has evolved into one of the most controversial scientific discussions of recent years, blending astronomy, institutional transparency, politics, and public trust in space agencies. At the center of this debate is Avi Loeb, a Harvard astrophysicist, well known for his outspoken views on interstellar objects and the need for openness in scientific inquiry. According to Loeb, the high-resolution imaging science experiment, HiRISE, camera aboard NASA's Mars Reconnaissance Orbiter captured the most detailed images ever taken of 3I/Atlas on October 2, 2025, when the object made a close approach to Mars. These images, he argues, are far superior to anything previously released to the public, including the widely circulated Hubble Space Telescope images from July 2025. Yet, despite the extraordinary scientific value of this data, NASA has so far declined to make the HiRISE images publicly available, a decision that Loeb claims has stalled critical research and raised serious questions about the agency's priorities. 3I/Atlas is only the third confirmed interstellar object detected passing through our solar system, following the discoveries of Oumuamua in 2017 and 2I/Borisov in 2019. Unlike typical comets or asteroids that originate within the solar system, interstellar objects are visitors from distant star systems, carrying with them information about planetary formation processes far beyond our own cosmic neighborhood. Because such objects pass through the solar system quickly, opportunities to study them in detail are rare and fleeting. Loeb has repeatedly emphasized that every moment counts when dealing with these cosmic interlopers, and any delay in releasing high-quality data risks permanently losing the chance to extract valuable scientific insights. In his view, the HiRISE images of 3I/Atlas represent a once-in-a-generation dataset that could significantly deepen humanity's understanding of interstellar matter. Loeb's criticism of NASA intensified when the agency cited the U.S. government shutdown as the primary reason for withholding the images. Officially, NASA suggested that staffing limitations and administrative constraints caused by the shutdown delayed the processing and release of the data. Loeb, however, has expressed strong skepticism toward this explanation, describing it as a politically convenient excuse rather than a genuine obstacle. He argues that NASA has continued to operate critical missions and release other forms of data during similar shutdowns in the past, making it difficult to accept that these particular images could not be shared. From his perspective, bureaucracy and institutional caution have taken precedence over the scientific imperative to share information promptly and openly. Central to Loeb's argument is the exceptional quality of the HiRISE images. The HiRISE camera is capable of resolving details at a scale approximately 3 times sharper than the best publicly available Hubble images of 3I/Atlas. Such resolution could allow scientists to determine the object's precise size, shape, and surface characteristics with unprecedented clarity. Moreover, one of the most puzzling aspects of 3I/Atlas is its anomalous tail, which appears to exhibit an unusual orientation that challenges conventional models of cometary behavior. Traditional comets develop tails that point away from the sun due to solar radiation pressure and the solar wind, but observations of 3I/Atlas suggest a more complex and less easily explained structure. High-resolution HiRISE images could help clarify whether this anomaly is caused by unusual composition, outgassing behavior, interaction with the interplanetary medium, or some entirely new physical mechanism. Loeb has repeatedly warned that withholding such data prevents researchers around the world from conducting independent analyses, testing hypotheses, and engaging in healthy scientific debate. Science, he argues, advances most effectively when data is openly shared and subjected to scrutiny from multiple perspectives. By delaying the release of the HiRISE images, NASA has inadvertently limited the diversity of interpretations and slowed the collective effort to understand 3I/Atlas. This concern resonates beyond the specifics of this object, touching on broader questions about transparency, accountability, and the relationship between publicly funded institutions and the global scientific community. The controversy also reflects Loeb's broader philosophy about science and exploration. He has long advocated for a more adventurous and less conservative approach to studying the universe, particularly when it comes to anomalous phenomena. In the past, his willingness to consider unconventional explanations, including artificial origins for interstellar objects, has attracted both attention and criticism. While many scientists disagree with some of his conclusions, even his critics often acknowledge that his calls for open data and rigorous investigation are fundamentally aligned with the core principles of scientific inquiry. In the case of 3I/Atlas, Loeb has stressed that releasing the high-rise images does not require endorsing any particular interpretation. It simply allows the evidence to speak for itself. The situation took a significant turn when Loeb announced, via a post on Medium dated November 14, 2025, that NASA is now preparing to release the high-rise images within a matter of days. According to Loeb, multiple sources informed him that the long-awaited data would soon be made public, marking a major shift in the agency's stance. He described this development as excellent news, expressing relief that the scientific community may finally gain access to the images needed to conduct timely and meaningful research. If this release proceeds as expected, it could help ease tensions between NASA and critics who have accused the agency of unnecessary secrecy. The anticipated release of the high-rise images is expected to reignite global interest in 3I/Atlas. Researchers will likely scrutinize the data for clues about the object's composition, structural integrity, and dynamic behavior as it passed through the inner solar system. Comparisons with the earlier Hubble images may reveal subtle features that were previously invisible, potentially resolving ongoing debates or raising new questions. For planetary scientists and astronomers, this moment represents not just the unveiling of sharper images, but the reopening of a scientific dialogue that many feel was prematurely constrained. Beyond the immediate scientific implications, the episode highlights the delicate balance space agencies must maintain between operational constraints, political realities, and their responsibility to serve the scientific community and the public. NASA operates within a complex framework of governmental oversight, funding limitations, and security considerations. Yet it is also entrusted with advancing knowledge and fostering international collaboration. The 3I/Atlas controversy underscores how easily trust can erode when communication falters or decisions are perceived as opaque. Even if the delay was not motivated by any intent to conceal information, the lack of clarity surrounding the situation has fueled speculation and frustration. As the scientific community awaits the release of the high-rise images, many hope the episode will serve as a learning experience. Transparent and timely data sharing is especially critical when dealing with rare and transient phenomena like interstellar objects. Once such an object leaves the solar system, the opportunity to gather new observational data is gone forever, making every dataset invaluable. The lessons learned from 3I/Atlas could shape future policies on how similar discoveries are handled, ensuring that bureaucratic delays do not hinder scientific progress at pivotal moments. In the end, the forthcoming release of the high-rise images may help shift the narrative from controversy to discovery. If the images confirm existing models, they will strengthen current understanding of interstellar objects. If they reveal unexpected features, they could open entirely new avenues of research. Either outcome would validate the importance of sharing high-quality data as quickly as possible. For Avi Loeb, the anticipated release represents a vindication of his insistence that science must come before red tape. For NASA, it offers an opportunity to reaffirm its commitment to openness and collaboration. And for the broader public, it serves as a reminder that the exploration of the universe is not just about spacecraft and instruments, but also about the values that guide how knowledge is pursued and shared.